So let's let p of x be equal to x to the 6 minus x to the 5 minus x to the 3 minus x squared minus x, and q of x be equal to x to the 4 minus x to the 3 minus x squared minus 1. Now if z1, z2, z3, and z4 are the roots of q of x, we have to evaluate pz1 plus pz2 plus pz3 plus pz4. So first we notice that the coefficients of these two polynomials are really similar, the first one being 1 and all the rest being -1. And so we think to use polynomial long division. After all, p of x probably divides q of x, since we're looking for each of these roots into p of x. So we have x to the 6 minus x to the 5 minus x to the 3 minus x squared minus x, all divided by x to the 4 minus x to the 3 minus x to the 2 minus 1. And so we have x squared at the top, then we have x to the 6 minus x to the 5 minus x to the 4 minus x squared. Subtracting this will then give us x to the 4 minus x cubed minus x. And so we get x to the 4 minus x to the 3 minus x, and then we get plus 1, so we get x to the 4 minus x to the 3 minus x squared minus 1. Subtracting this will then give us x squared minus x plus 1. And so the remainder when p of x is divided by q of x is equal to x squared minus x plus 1. And so we can write p of x is equal to q of x times x squared plus 1 plus x squared minus x plus 1. And since z1, z2, z3, and z4 are all roots of q of x, that means that when p is equal to z1, that means that q of z1 is equal to 0. And so p of z1 is equal to z1 squared minus z1 plus 1. And so now doing the same thing for pz1, pz2, pz3, and pz4, we then get that pz1 plus pz2 plus pz3 plus pz4 is equal to z1 squared minus z1 plus 1 plus z2 squared minus z2 plus 1 plus z3 squared minus z3 plus 1 plus z4 squared minus z4 plus 1. And so now I'm going to move this to the top and then continue solving. But now remember that q of x is equal to x to the 4 minus x to the 3 minus x squared minus 1. And so now we can use Vienna's formulas to solve for z1 plus z2 plus z3 plus z4. And so z1 plus z2 plus z3 plus z4 is equal to 1. And so negative z1 minus z2 minus z3 minus z4 is equal to -1. And so adding all of the ones and then combining all these terms will then give us that we are to solve for z1 squared plus z2 squared plus z3 squared plus z4 squared minus 1 plus 4, which is equal to 3. And so now we can apply our second Newton sums to this problem. And so we get an s2 plus an minus 1, s1 plus an minus 2, s0 is equal to 0. Now s0 is equal to 2, and s1 is equal to 1. And so we have an s2 plus an minus 1 times 1 plus an minus 2 times 2 is equal to 0. And now substituting 1 is equal to an, negative 1 is equal to an minus 1, and negative 1 is equal to an minus 2, we then get that s2 minus 1 minus 2 is equal to 0, and so s2 is equal to 3. And so z1 squared plus z2 squared plus z3 squared plus z4 squared is equal to 3. And so z1 squared plus z2 squared plus z3 squared plus z4 squared is equal to 3. And so 3 plus 3 is equal to 6. And so 6 is our answer, and we are done. Alright, thanks for watching. Hopefully you enjoyed, and hopefully I'll see you next time.